Hi and Assalamualaikum. I am Ainul Mashita binti Azhari and my metric number 227313.
My name is Shaza Isina Balkis binti Arifin and my metric number is 228553.
Hi, my name is Muhammad Abrisham Adwa bin Hishamuddin and my metric number is 229651.
My name is Nur Satinin Shira binti Wahid and my matrix number is 229215.
My name is Muhammad Ilham Lutfi bin Abdul Latif and my matrix number is 227569.
My name is Nur Aliana Nasuha binti Abdul Razak and my matrix number is 229225.
Hello everyone, my name is Nur Atira Shami binti Rohimi. My matrix number is 227687.
Hi, my name is Amira binti Rosli and my matric number is 227346. Today, our group will be presenting about our data analysis, which is salary versus experience. This study analyzes salary data using SAS statistical software, which is used to manage and perform statistical analysis on data efficiently. The main objective of this study is to summarize salary data and to examine relationship and differences between selected variables such as age, gender, education level, job title, year of experience, and salary. The data set consists of 6 related variables, include both numeric and character data types. By analyzing this variable, we can better understand salary patterns. Several statistical methods such as hypothesis testing, correlation, regression, and ANOVA are applied to identify significant factors. Next, I will explain the objective of this study. The first objective is to interpret SAS output and draw appropriate conclusion. The second objective is to examine the relationship between salary, age, and years of experience. The third objective is to determine whether there are significant differences in salary based on categorical variables such as gender, education level, and job title. Lastly, this study aims to apply statistical tests including hypothesis testing, correlation analysis, regression analysis, and analysis of variance or ANOVA in order to make statistical inferences.
So for the methodology, firstly we do data preparation. For the data set, we use the real data set with 6,704 observations. For the descriptive analysis, EDA, for the statistic, we calculate the average, median, and spread using prog means. And for the graphic, we generate the histogram and box plot. Via prog-ski-plot, we visualize how salary is distributed across the sample. And lastly, for the inferential testing, we have 5 tests, which is the first one is hypothesis testing. We test if the average salary different from a 110 benchmark, and here we use prog t-test. For the test of independent, we check if the gender and education level were related, and we use prog frequency. And the third one is correlation, to measure the strength of the link between the experience and pay by using prog core. And for regression, we create a model to predict salary based on years of experience using prog regression. And lastly, for ANOVA, we compare mean salary between junior, mid-level, and super senior group, and by using prog DLM.
Okay, so for test for this data set, for the first one, we have used descriptive statistic and EDA to give the summaries of the data and the visualization of the data. So for descriptive statistic, we choose prog mean procedure to give all 6699 value records, and it shows that the mean is really close to the median, and it shows that data has a normal and balanced distribution. So for the EDA, we have used the histogram and the scatter plot. For histogram, for the graph of the salary, it is spread across a wide range. And you can see the blue curve represent a normal distribution with a mean of 115327, and even that the data has a several peaks, but the overall shape is relatively balanced. And then based on these 3 tests, you can say that the p-value is less than 0.005, so we can reject the H-null and we conclude that our dataset does not follow a normal distribution. And then next, we can look at the years of experience among the individuals in our dataset. So average is about 8 years of experience, but we can look at the mode that is 2 years, so we can say that mostly is about junior professionals, and the skewness is value of 0.98, that is a positive skew, so that's meaning that the weighted heavily towards few years of experience. So this explains that why our area test show the data does not follow a normal distribution. So for histogram of the years of experience, the histogram is positively skewed, and then for the p-value is less than for 0.0001, so we can say that this our data set is highly significant. And then secondly, for EDA of scatter plot, to analyze the relationship between the years of experience and the salary. So we can look at the red regression line. It shows that the clear positive correlation between these two variables. So we can say that when the years of experience is increased, so the salary is also increased.
So, For the estimation, we use prop means to obtain the descriptive statistical estimates. The mean salary is 115,326.96 with a standard deviation of 52786.18. And the mean years of experience is 8.09 years with a standard deviation of 6.06. This is show that the wide minimum and maximum values indicate high variability in salary and work experience. So next, we move on to the hypothesis testing. For the hypothesis testing, we use prop t-test to examine whether there is a significant difference in mean salary between employees 5 or more and less 5. The mean salary for the 5 or more group is 144,443, that is higher than the less 5 group, which is 63410. And the table for the 95% confidence interval for the 5 or more group is 143275 until 145610, that is higher than the less 5 group, which is 62255 until 64564. So the confidence intervals do not overlap, and this shows that a clear difference in the mean salaries. So next, we move on to the table equality of variance. The t-test shows P is less than 0.001, indicating unequal variance. Therefore, the Satterthwaite method was applied. The t-test shows that the P is less than 0.001. So we reject the null hypothesis, and we can conclude that there is a statistically significant difference in mean salary between two experienced groups. So next, we move on to the graphical analysis. For the histogram and box plot, it shows that the salaries for the 5 or more groups is higher and approximately normal distributed, while the less 5 group shows that the salaries are lower, right skewness, and have several outliers. Lastly, for the QQ plots graph, it indicates that the 5 or more group is approximately normal, while the less 5 group divides from normality. Even though it is for the less 5 group is divided from normality, the t-test is robust to normality violations, but the results should be interpreted with caution.
And the next one is the test of independence. So based on the table, this provides the breakdown of the education level for male and female across the category, like bachelor, high school, master, and PhD. The majority of both gender fall into the bachelor degree category, which is male is equal to 20.18% and female is equal to 13.18% of their respective total. So for the null hypothesis, H null is education level is independent of gender, and HA is education level is not independent of gender. For the test statistic, F value is equal to 383.5499, and the p-value of the hypothesis test of gender and education level is equal to 0.001, which is less than alpha 0.05. Since the p-value is less than 0.05, we reject the null hypothesis. We do not have sufficient evidence to conclude that the education level is independent with gender at 5% significant level.
Part is 4.4 correlation test. The figures show the descriptive statistic for years of experience and annual salary. The correlation table presents the relation between years of experience and salary, and correlation coefficient is R equal to 0.80897, and the hypothesis for the correlation is H null P equal to 0 and H1 P not equal to 0. Since the p-value for correlation between years of experience and salary is less than 0.0001, smaller than the significant level, which is 0.05, thus we reject H null. In conclusion, there is sufficient statistical evidence to conclude that there is a significant linear relationship between years of experience and salary.
So our data set is about salary versus years of experience. Function to do the linear regression is to predict the salary based on years of experience. We look at the output table at the model. At the F value, we got 1 to 682.6, and the P value less than 0.001. So this one is indicate that years of experiences is significant predictor of the salary. Again, the model explain approximately 65.44% of the variance in salary R square equal to 0.6544. So from the table also we can estimate the regression equation, which is salary equal to 58,283 plus 70,046.76 times years of experiences. So the B note is actually 52283 and the B1 is 7046.76. So from this, it actually indicates that for each additional years of experience, salary will increase by 7046.76 on average. So from this also, both the intercept and the slope were statistically significant from the p-value that we got. So again, confirming that experiences and the salary have the strong positive relationship.
Next is one-way ANOVA. The Levin's test shown that the variances are not equal, so the ANOVA test remains robust. And then the second one is hypothesis test. From the ANOVA table, the p-value is 0.001, which is less than alpha value 0.05. So the conclusion is there is significant difference in the mean salary among junior, mid-level and senior employees. The third is Tukey test. Post-hoc test revealed that there is strong statistical evidence to support the claim that salary increases significantly as experience level increases from junior to senior roles. The box plot visualizes the significant difference in salary range, clearly showing that the median salary increases progressively from junior to senior level, supporting the ANOVA and post-hoc results. The last one from ANOVA is R-square. The R-square value is 0.634, which means that 63.4% of the variance in salary can be explained by the employee's experience level.
I will be explaining about the result of our two-way ANOVA test. The purpose of this test was to look at salary through two lenses simultaneously, which is age group and experience group. By looking at our overall model, we see an F value of 3151.58 with a P value of less than 0.0001, which tells us the model is highly significant. More importantly, our R-square is 0.653174, which means that just by knowing someone's age category and their years of experience, we can explain about 65.32% of the variation in their salary. Now, if we look at the individual factor, what we call the main effect, we see that the both variables are powerful predictor on their own. First, age group show that the F value is 1777.12, and secondly, experience group show an F value of 82.09, which both have P value below our alpha of 0.05, which means we officially reject our null hypothesis. Because we found significant result, we perform a Tukey post-hoc test to see exactly where the difference lie. For experience, we found that every group is statistically different from others. Unsurprisingly, the senior group earned the highest mean salary. For age, we also found significant difference across all three categories, young, middle, and senior. Even when we adjust for experience, older employees tend to have higher mean salary than the younger group. In conclusion, we have sufficient evidence to say that salary is not just about how long you've worked, not just about how old you are. It is significant combination of both. Both factors are independent and critical determination of income level.
Is actually the steady use of the SAS to analyze the salary data that we actually perform. So from our data, different statistical methods were applied, such as hypothesis testing. We try also the correlation analysis, linear regression, ANOVA, EDA, and something like that. So the analysis identified clear pattern and differences in the salary level. So that I also notice that the salary is influenced by several factors, including age, years of experience, education level, genders, and the job title. And also the salary generally increase by more work experience and higher age. What I can conclude also, study shows that the importance of the statistic in the understanding real world data and making evidence based on decision. So that's all from our group 1. Thank you for watching.